Good morning, viewers. I am still Pelumi. I'm here this morning, Friday, 19th of August, to continue the class, our mathematics class for SS1. For SS1, as we know that um, for SS1, so JSS3 will still make a lot of benefit from this video, GS3. But mainly I want to extend it to SS1. And in SS1, we call it what? Number system. So number system is beyond binary. Is beyond binary. So we have it more than binary. So under it, that's where we have binary. That we say is what? Base 2. The common one we have say sometimes they call it decimal or some call it denary. That is base 10. Base 10 being the bulk of it, and because it's the main point. Now go out from other base. Now let us know as a student or teacher teaching that class that any base that you are moving towards, for instance, if I have 2, 4, 3, my base can never be less than any of this. So the least base that I will have here is base 5. The least base that I will have here is what? 5, because the base has to be greater than any of this. So let's just have that in mind. Now, let me just make a kind of revision on how to convert from base 10 in a more faster way from base 2 to base 10. So let's call it recall. How to recall. So we said, for instance, they said convert 101101 base 2 to base 10. So this, if I'm asked to convert this, is very, very, very simple. Just straightforward. I just want to use a kind of short method. Now let's write 101101 for very smart kid or very smart student. Should know that we normally say this is base 2, we write our 2 here, and 2 will be raised to power 0 for the first one. Definitely, the first one will give us 1 if this place is 1. So if this place is already, we ignore this, in order to get our answer in case of quiz and something like that. And definitely we know after 1 it should be raised to power 2. Of course, raised to power after 0 is raised to power 1. Our raised to power 1 is supposed to be 2, ordinary 2. But because 0 is there, we cancel it. And the next one is supposed to be 4. The next one is supposed to be 16. The next one, that's like multiple of it. This 32, there's 64. So my boy here said yes, yeah, that's correct. We have 2, 4, 8, 16, 32. So meaning this one you don't have much problem. So this is out of it. This is out of it. This thing that they are just here, I am talking about when it is base 2. Because this is 1, 1, 1, 1, 1. 1 multiplied by anything give you that thing. So this will just give me 32 plus 8 plus 4 plus 1. This very fast way. So we have 40 here and we have 45. 45 base 10. This one is very, very fast. Very fast. So let me see, give another one. Let's say we have 0001 base 2. Now I want to convert it to base 10 Very easy. I know the first one will surely be 1. The second one is 2. The third one 4. Then 8. Because power 1 will be 1. This one will be power 0, power 1. So the next one will be 16. So I will cancel this out, cancel this out, cancel this out. So I will be left with 16 plus 1. My answer will just be 17. I'm talking about in terms of objective and quiz. So I just give these tips. Now let's go to the main work. And the main work here is SS1. How do we convert from one base to another? We said conversion from one base to another. Now, we are not going to the garage. Our garage is base 10. We are coming from base 2. We know that one. Very clear. Now, we want to come from other base to other base. So, example, let's pay attention. Example, we have, let's say from, I'm given 212 base 3 to base 4. Now, there are two different bases. So, the type of method that I normally employ is come to base 10 first. Then from base 10, go to base 4. Very simple. And let's solve it this way. 2, 1, 2, 3. Okay, let me come to base 10. Like I said, my 3 will be here, 3 will be here, 3 will be here. Power 0, 1, 2. Multiplication, multiplication, multiplication. So all this plus all this plus all this. Very simple. So I have 2 times 3 raised to power 2 plus 1 times 3 raised to power 1 plus 2 times 2 raised to power 0. So there we have is equal to 2 times 9, 1 times 3, and 2 times what? Anything raised to power 0 is what? 1. So this one will give me 18, add 3, add 2. So this will give me 20, 23 base 10. Then don't forget, I am going to base 4. Then I convert it to base 4. If I'm going to base 4 from base 10, I make it in this form. I write my remainder. So I'm talking about 23. So let's divide by 4. 4 in, how many 4 in 23? I think 20, and that is 5. It will remain 3. So 4 again, we'll still divide by 4. 4 in 5, 1, its remainder 1. Then 4 in 1, it is impossible, then we'll write whatever is there. So you read it upward. So therefore, we have 212 base 3 is equal to, from down, 1, 1, 3 base 4. So this is how to go from one base to another. You first come to base 10, then you move to base 4. Then let's go to how do we convert binary of decimal to base 10. We say conversion of binary or decimal binary. Let me say this decimal binary to base 10. Then this one is quite simple, very simple. So like you just follow your number line, but then let me just say I'm given 1 is 0, 1.11. Okay, let's say 1 is 0, 1, 2. Everything base 2 to base 10. Are we there? Yeah. Normal, this is our whole number. This is our whole number, but this is our decimal fraction. So we have 100.100 base 2. Since we say it's base 2, let our 2 stay, let our 2 stay, 2 stay, 2 stay, to stay. All right. Then I will use my number line. My number line, this place is point 0. Then we have the first one to be 1. To the right hand side, that's your 1. That's positive integer. 2, 3, 4, and like that. But to this side, we have my negative integer to be -1, -2, -3. So now it's like this our number line is turned upside down. Now, this is our main number. This is our positive. Our positive is at this side now, so we follow this rule with it. Then our negative is at this side. We follow this rule of negative with it. So here I have to power 0. And like I'm starting here, this is my positive. And these are positive here. So power 0, power 1. Now I'm starting from 0, 1, power 2. Stops there. But this one, I'm starting from this. I'm going towards a negative. And this is the other side. This is the other side of it. This is the positive, of course. This will be the other side. So this one will now be, after 0 is what? -1. After 0, -1. This one -2. This power -2. This one to the power of -3. Then we can now put our multiplication, and we begin to add each of them like we normally do. Multiplication, addition in between. Addition in between. Now let's apply that. This will now be 1 times 2 raised to power 2. Let's add. Oh, like I told you that time, always disregard that 0. So let's it go. But for theory's sake in WAEC, I think you need to spell it out. I mean the senior WAEC. So we have this raised to power 0. Add. Now we are coming to this side. 1 times 2 raised to power -1. Add. Like this one. Someone say, let's still put it. So, and we have 1 times 2 raised to power -3. So this will now be equal to, this one will give me 1 times 4. This one will give me totally 0. Don't let me disturb myself. This is 0 plus, and this one will be 1 times 1. Okay? Plus, this one will now be 1 times what? This means 1/2. So it's inverse. It means 1/2. This negative. When there's 1/2, the complete number will come down. And this is t to power 1. So this one is 0. Let me move to this one. That will be 1 times 1/2 raised to power 3. Like this. So this one will now have this one 4 plus 1 plus 1 times half, it remains half. And 1 times this, it remains that number. 2 raised to power 3, that's 8. So here we have this one to be 5. That will be our whole number. 6 is coming from the front. And this one, you can find your LCM, and that gives you 8. That's 4. How many 2 in 8? 4 times 1, of course, is 4. And this one, 8 in 8, 1. And that gives me 5 whole number, 5/8 base 10. So this is how to convert decimal to base 10. This is how to convert decimal to base 10. About SS1, there is no doubt about that. We'll still move to, how can we now move back from base 10? From base 10, to binary. I mean fraction or decimal. So our answer to could be in form of decimal. Let me put our answer in decimal. We got 5 whole number. I think 3/8 base 10. So 5/8 base 10. So let's put this one in decimal. I think it will remain 5. How many 8 can we get in 5? Is impossible, and that's point. I add 0 to this invisible 0, like we normally say. 5 in 50, 50. I think that's 6 is 48. So that's 6 remainder. So 48 it will remain 2, isn't it? So in 8 that's 2. So that's 16. 16 to now be 4. So in 4 it will be what? 5. So this is it in decimal. So it could be like this. This is the fraction, this is the decimal. That's why I said this one in fraction or decimal. So any of the two is 10. They might give you any of this and say convert to binary. You can say convert to binary, that is base 2. Base 2. So how do we go about it? Let's start with this. If you are asked to convert this fraction to binary, 5 over 8. So I'll first deal with this whole number. His whole number on its own. I'll do it like LCM 5. So 2 there, 2 remainder 1. 2 again. Since I am going to binary, that's why I'm using 2 to divide. Any base I'm going at, that's what I use to divide. So 1 remainder 0, 2. We said impossible, we write this one down. So I am getting 101 base 2. That is before point. Like before point. This one before point. So what about 5 over 8 base 10? 5 over 8 base 10. So in fraction, what I do is that numerator, I work, like I said that time, I said the first number goes with 1 when we're converting it. I said the second one, 2. The next one, 4. The next one, 8. This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So these things, they are very important. They are very what? Important. So we are going to use this now. So to get this 5, let's go. I'll start from 1 plus, I move to 2. I think that will give me 3. I move to what? 4. Because this 3, I can't stop on it. It will not give me 5. But this one now, it will give me 5 more and more than is okay. Then each of them over 8. Are we there? Now, so with this, I have not fulfilled it. It's only 5 that I need, but if I add this one, it's 7. So I have to cancel 1. That will make it 5. So the one that I'll cancel is this one. So that it will be able to give me 1 plus 4, 5. That's the numerator. Then this one, so I have cancelled this. So I only have 1 over 8 plus 4 over 8. Then let's continue. We have this. This will now be equal to, like I told you, let your equal to be what? To be in line, so that it will. Then what I do here is that I will like change it. I will bring the one at the back from the back. I'll start writing it from the back. So it will be equal to, I have 4 over 8 plus what? 1 over 8. So this one will not give me. So what is giving me all this is 5 over 8 base 10. So if I call this one to give me 1 over 2 and this one 1 over 8, then don't forget this 1 over 2 is the same thing as 2 to negative 1. And this one is what? 1. Okay, let me make it like this. 1 over 2 to raised to power 1. And this one is what? 2 raised to power 3. So this one will now give me 2 to negative 1 plus this one will give me 2 to negative 3. Like I told you that this one will change. Now, if now there is something missing, if there is nothing missing, you know definitely what we did that time in that number line. The first one there, if it is 1, it's going to be raised to negative 1. The next one, negative 2. No negative 2 here. You have to represent it with what? 0. Then negative 3 is there. It will still be 1 because 1 multiplied by it will give me this. So all this one that I'm saying, they are after points. So the first one that I got is what? 101. So it will not be point. This one, 101 is 2. So therefore, 5 whole number, 5 over 8 base 10 will be equals to 101, 101 base 2. So this is how to successfully convert to but what about if it's in this form? How will I go about it? It won't take the same way. Of course, let's try that one so that we'll use it to round up this video. 5.625 base 10. Now I want to convert it. But when they give us in this form, they normally tell us to the digits that will stop. You can say maybe up to digits, or they can say 3 decimal place. That is just 3 number after the decimal point. Of course, we know how to convert this. It's the same thing, the way we converted it here. But our problem now is this, when I was talking about decimal, place value of decimal in basic 4, I made mention that any number here will be 0 since I didn't name them. Even though there are 10 numbers, all will be represented with what? 0. Then the one after 2, because this is the one I actually knew. So there are different methods that we can use. You see, this place is positive. Here is negative. Here we always do the opposite of what this side is doing. I'll do it the same way like this, but it will do the opposite of what this one is doing. Now let's go. We said we have 0.625. Now I want to convert to base what? 2. To base 2, don't forget. Now here, when we wanted to convert to base 2, we started dividing. We did what? Division. Here, we'll do the opposite, multiplication. As division and multiplication, they are what? Brothers. So I will multiply by 2. Okay, let's multiply. This gives me 10. I take 1. This 4, 5. This one gives me what? 12, right? 12. So let me count the number after point. 1, 2, 3. And of course, that's what I'm after. 1, 2, 3. I insert my. Then I go to the next one. Since they tell me that 2, 3 digits, I want it. Does it finish at 3 digits? So that's what I'm after. Now I still multiply by 2. I continue to multiply since I'm dividing at this side. This is the inverse. For instance, if I write 4 and say what is the inverse, just say 1 over 4. Because every number will always be over 1. The inverse is you reciprocate. You do what? Reciprocate. The denominator goes to the numerator. So that is just it. Very simple. Okay, let's multiply the second one. I have this will give me 0, of course, and this will give me 10. I take 1, and this will give me 4, making 5. So I am concerned with the number after point, not the one before. So this one now, if I am to count, I will count 3, isn't it? 1, 2, 3. Let's count 1, 2, 3. Point will be here. It means there's nothing at the front. So they said 3. I'll still multiply by the 2 since I'm going to base 2. Are we there? So this one will give me 0, multiply 0. This one give me 10. I take 1. So, okay, of course, the 1 will come. Since it's 10, there's nothing to multiply because I'm concerned with this number. So I count 1, 2, 3, 1, 2, 3. So now, all this number before point is now my answer. They are my what? Answer. Not from beginning, but rather from here. You look at this arrow. I said you will read it upward here, but here you will read it downward. You see that everything, the positive side do this, the negative side will do the opposite. So I will read it downward. So it's going to give me, since I have gotten this one to be 101, then point, this one, I will now read it downward, 1, 0, 1, base 2. So if you are given in this form, that's how you go about it. If you are given in this fraction form, you go about it in this form. The next one here will be 16, 32, and like that. It depends on what 2 is raised to. So we have come to the end of this class for SS1, and I think I'll still do more video to complete the aspect of their what do you call it? Or the aspect of some of their fraction that there could be big fraction. So have a wonderful time.